Confidence intervals for means. A confidence interval is a range of values that estimate the population mean. The process begins with finding the mean from a sample of the population. So let's say we want to know the average age of all Cerritos College students. So we want to know the population average, which we call mu. It's going to be difficult to get that, so instead we just sample 45 students and we get the average age of those 45 people. So what we have is we get X bar, and X bar comes from the sample, and it's the average age of the sample. And we're going to estimate the population proportion using what we know of X bar. The population mean, we're going to estimate the population mean from what we know of X bar. So most likely our X bar will not be equal to the true population mean. There will be a sampling bias in the estimate, which we'll consider by tacking on a margin of error. So our confidence interval is going to look like this: X bar plus or minus some error. Now we know if some requirements are met, that the X bars will be normally distributed, or at least bell-shaped, with a mean of mu. Their center is mu, and their standard deviation is the population standard deviation divided by the square root of the sample size. And so that standard deviation we call standard error. So the standard error, the natural deviation of the sampling distribution, we sometimes refer to as SE, that's going to help us in our margin of error. Our margin of error, M, is going to be the critical value times the standard error. And the critical value just tells you how many standard errors you need to include to get a particular margin of error. So this critical value is going to come from our confidence level, and we already know where the standard error comes from. It comes from sigma over the square root of n. Remember, if you don't know sigma, you can also use S, the sample standard deviation, to approximate it. So let's go over the requirements when estimating a mean. Let's go over the requirements that make sure that the central limit theorem kicks in and we know our standard error can be approximated, and also which distribution we're using. First requirement, again, the simple random sample that's probably going to be given to you. And then the next requirement is just that either your sample comes from a normally distributed population, that's the original population of X's, has to be normal. And if it's not normal, your sample size has to be bigger than 25. So, then for the mean, there's also another thing you need to check. If your sigma, if your population standard deviation is known, then what this means is that you're going to use the normal distribution or the Z distribution to find your critical values. To find your critical value. But most likely, sigma is not going to be known, because why would you be estimating the mean if you didn't know sigma? So if your population standard deviation is unknown, then you're going to use what's called the T distribution. It's another bell-shaped curve that is a better estimate when you don't know sigma for your critical values. And the T distribution has a degrees of freedom that is n minus 1. So for both of these, though, remember your standard error is still going to be sigma over the square root of n. But if you don't know sigma, as in this case over on the right, you're going to use S instead of sigma. So here's an example of building a confidence interval for a mean. A large loan company specializes in making automobile loans for used cars. The Board of Directors wants to estimate the average amount loaned for cars during the past year. So there's what you're trying to do. You're estimating an average. The company takes a simple random sample of 225 customers for this period. So that tells us that N is 225. The mean amount loaned for this sample of 225 loans is $8,200. So that $8,200 is not the population mean. That is the sample mean of those 225 loans. So we know X bar is equal to $8,200. The Board of Directors believes the population standard deviation is $750. So this is given from past information. That 750, they say that's the population standard deviation. So that sigma is going to be equal to $750. And then the last thing that they tell us is to construct a 90% confidence interval. So our confidence level is equal to 90%. Okay, so here's what we know. N is 225. Our sample size is 225 car loans. Our sample mean was $8,200 was the average car loan for the sample. And who is it? The people in charge at the company, based probably on past data, they think that the population standard deviation is $750, and they want a confidence interval at 90% confidence. And keep in mind, we're trying to estimate mu, the population average car loan amount at this company over the past year. So far, our confidence interval is going to be our start of our X bar, give or take some error. And so far we know that our sample mean loan was $8,200. So we figure that our population loan amount will probably be around there. And then it comes down to finding M. And remember, M is the critical value times the standard error. But before we can do this, we've got to make sure that everything's in play and check our requirements so that we know we're creating a valid confidence interval. The first requirement, is this a simple random sample? Yes, we were told it was. And number 2, N is equal to 225. We weren't told that this population is normal, but we were told that N is definitely bigger than 25, so we can proceed. The next thing we need to make sure we're aware of is that sigma is known. Sigma is $750, so therefore we're going to use the Z distribution, not the T distribution. If sigma were unknown, we would use the T distribution to find the critical values. I know that the standard error, now that I know all the requirements are met, the standard error is going to be the standard deviation divided by the square root of N. So that'll be 750 divided by the square root of 225. So our standard error ends up being $50. So here's where we're at with our confidence interval. We need the margin of error, and we already have these standard error for that is going to be $50. But now we need the critical value. And we're going to get the critical value using our Z distribution. So there's our normal curve. And it's with 90% confidence, so the middle value is, middle area is 90%, and so we need our critical values on the outsides. And we're going to get those. I'm just going to look at the one on the left to obtain that critical value. And I get the critical value is going to be inverse norm. And the area to the left of that is going to be 0.05 because we've got 10% on the outside and half of that would be 0.05. So I get my critical value of 1.645. The left side is negative, the right side would be positive. So going back to my margin of error over here, I'm going to have my margin of error is now 1.645 times 50, which is $82.25 that we have to tack on to our error of loan values. So now with the margin of error, our average car loan is estimated to be between $8,117.75 and $8,282.25. So that is your confidence interval for the mean. And then a follow-up question may be, suppose you're a student and you're looking to get a car loan from this company and you need a loan for $81.50. So if you need a car loan for $8,150, would you expect that you'd be able to get a car loan here? And I think you might, because $8,150 is in that interval. So hopefully, you'd have to check your credit and everything too, but at least the company is into giving out loans for that amount. The end.